Our next speaker is Professor Dr. Hou Deyi. Professor Hou Deyi is a AE, or is associate professor at Tsinghua University. He got his PhD at Cambridge University, and currently he is the editor-in-chief and AE of a couple of top journals. His research interests cover soil and groundwater remediation. Today, his topic is green and sustainable remediation of contaminant site, going beyond the temporary and spatial boundaries. So, Professor Hou, please.
Okay, can you hear me?
Yes.
Okay, thank you, Professor Du, and many thanks to the organizer of this ISEG conference, and I feel very honored to have this chance to talk in front of this community. My talk today will focus on green and sustainable remediation. First, let me share my screen. Let me see. Can you see my screen?
Not yet. Yeah, it's coming out.
Okay.
Yeah, perfect.
Okay, great. To talk about green and sustainable remediation, first I want to talk a little bit about the background. The green and sustainable remediation movement occurred, primarily because of the general sustainability movement in the modern society. And there were a lot of talks about development over the last few decades. And the main reason is that both scientists and the government and the general public realized that there is a limitation in the amount of resource and the ecological capacity on our Earth take on because of the a rapidly increased global population and the improved living standard. We cannot maintain a healthy planet based on this trend. And on this slide, I'm showing a figure from a recent report from the international organization. It shows that back in the 1970s, for the population and the living standard back then, we can.
Sorry, Professor Hou. We can't see you. We cannot see the slides in the screen. Can you?
Oh no. Okay, let me see. No. Hide. Let me see. Can you see it now?
Not yet. Not really.
No. Okay. Let me. Maybe I'll stop sharing. Let me see. Let me share the.
Please try to reshare the.
Okay. Let me see. Can you see it now?
Yeah, it comes. Yes, it comes.
Okay. Okay, good. I am going to the next slide. Can you still see it?
Yes.
Okay,
perfect.
Good. Okay, good. Okay, so the sustainable development movement has advanced to a new stage in the recent years. In 2015, the United Nations passed a new resolution. Now we have a 2030 agenda in which we have 17 sustainable development goals. Most of the researchers in this audience probably know. In the next 10 years, I think the scientific community, in almost all disciplines, will work very hard to help the international community to achieve these goals. And among these goals, more than half of the SDGs have a very close link to soil and groundwater pollution, most specifically to contaminated sites. So I'm showing this slide to indicate that contaminated soil and groundwater have very close link to the US SDG, and that supports the green and sustainable development, green and sustainable remediation movement. When we talk about sustainable remediation, sustainability assessment is a very critical component. And the reason we need to do sustainability assessment is that traditional decision making tended to ignore some externalities. For example, traditionally, when we try to select a remediation alternative, we usually do not look at the carbon emission. We do not look at the potential pollution that occurs outside of the site boundary. So conducting a sustainability assessment is to look at those externalities, which goes beyond the traditional spatial boundary and also temporal and categorical boundaries. Another important component of sustainable remediation is the sustainable behavior. Human behavior is very important in determining what kind of environmental consequence we will have when we conduct any work, either in industrial production or in environmental protection work. So here it involves both individual behavior and organizational behavior. For sustainable remediation, we are more concerned about organizational behavior, which is about the behavior from the different working parties and also the regulatory oversight bodies. Now, having talked about some general background, I want to talk more about the remediation. The remediation industry started about 5 decades ago in the 1970s. It was primarily driven by some high-profile cases in the United States and in Europe. Because of this, in the early days of the remediation industry, the public and regulators demanded a very aggressive remediation approach, and we call it remove all. Basically, the public and the regulators want the polluters and the liability holders to remove all contaminants from a contaminated site. However, after a few decades, scientists and governments, based on a lot of research, they found that it was not feasible from a technology perspective, and it was also cost prohibitive to use such a remove-all approach. So in the 1990s and in the 2000s, a new risk-based approach become more popular, and it become the mainstream. And in the most recent decade, there is an emerging green and sustainable remediation movement. And my talk today will focus on this new paradigm and the new norms associated with sustainable remediation. In this chart, I want to use the number of publications to show the development of green and sustainable remediation. The pretending concept first emerged in at the end of the last century. Most particularly around 1999, there were some life cycle assessment studies examined the life cycle impact of remediation. I think that needed some foundation for more scientific research and more debate in the remediation community. So in the early 2000s, some remediation organizations, most particularly NICO, which is the Industrial Association, and Contaminated, which is a intergovernmental organization, they both promoted sustainable land management. And then a few years later, in the United States, Sustainable Remediation Forum, an association with partners from both the industry, industrial associations, and the governments, and the SURF organization become a main driver for sustainable remediation. And in 2008, the United States Environmental Protection Agency started to publish a series of technical guidelines. And this was driven by two presidential executive orders that was published earlier. And that executive order was demanding more sustainable means in all federal agencies. And then the US EPA, I think, took that as an incentive to promote green remediation in the US federal agency, most particularly in Superfund projects. But that pressure was passed on to other projects and other types of projects and regulatory agencies as well. Since then, there were a lot of development in the international community, including a lot of national sustainable remediation forums and the international, the ISO standard published in 2017, and so on. So from the chart, you can see the number of publications went up very quickly. Actually, in the past few years, it went up even more quickly. I think I did a search just a few days ago, but I didn't get a chance to update this figure. In 2020, the number of publications has already exceeded 1,000. So we can see the rapid increase in this field. Now, having given an introduction, next I want to talk about the concept of green and sustainable remediation and the so-called life cycle net benefit of remediation. Right now, in the remediation community, there are actually three concepts. There, in Europe, the sustainable remediation was the mainstream. In the US, people are using green remediation more often. This is primarily because the US EPA doesn't have the Congress authorization to promote the social and economic components. So they used the green remediation term to promote this. But more recently, I think the green and the sustainable remediation, which combines green remediation and sustainable remediation, become more popular. In China, we are adopting the GSR concept. But all these three concepts have similar definitions. The concept is essentially to maximize the overall environmental, social, and economic benefits. And in that optimization, we look at the net benefit, which means that we not only look at the positive health benefit that remediation brings, but we also look at the negative impact, for example, the environmental footprint and other socioeconomic impacts. So in this concept, it's very important to quantify or quantitatively evaluate what's the net benefit. In order to evaluate this net benefit, it's necessary to go beyond the existing boundaries. This is a chart that I took from a US EPA publication, which divides the pertaining processes into 3 levels. The level 1 process is related to what happens at a contaminated site. For example, when we do remediation, we need to construct some remediation wells. We need to treat groundwater, and in bioremediation, we need to inject some reagents. All these processes occur at the site, and this is called the use phase, and this is level 1. And level 2 is the transportation stage. This is about the material being transported from an offsite facility to the site. So this involves a lot of transportation processes. And the 3rd level is about the raw materials, about the energy, about the equipment that are manufactured in offsite facilities. And this manufacturing or acquisition process will also cause a lot of environmental impact. So that is level 3. Now, traditionally, we only look at level 1. But in order to look at the life cycle impact, we have to look at all 3 levels. And this means that we need to go beyond the existing boundary in the existing in traditional decision-making process. In addition to this spatial boundary, we also needed to expand our temporal boundary. Traditionally, we look at the current site use. I mean, we look at the risk associated with the site use. But we usually do not look at the consequential impact, which means, for example, if we remediate a site for residential use versus we remediate a site for commercial use or for industrial use, under these 2 different site use, the future environmental footprint and the social and economic consequences are very different. So if we remediate a site to a more clean or cleaner standard, more stringent standard, we may be able to develop it for for future site use with no restriction. But if we cannot remediate it to such a stringent standard, if we use a more loose standard, then we may only be able to use it for industrial use. Then this has implications of its future environmental emission and the social and economic impact. And also, traditionally, we primarily look at the environmental impact, and we rarely look at the social and economic impact categories. But in order to achieve sustainable remediation, we need to look at all 3 impact categories. So all these 3 aspects we need to expand and go beyond the existing boundaries. In traditional decision-making for remediation, we also rely upon a health risk assessment. However, there are some shortcomings of the health risk assessment approach. Firstly, it only looks at the risk level. It doesn't look at the amount of work or the volume of contaminated media associated with this risk level. Here, I want to use 2 graphs to show the difference. For example, at site A, when the acceptable risk level becomes more stringent, taking cancer risk as an example, if we go from 10 to -4 to 10 to -6, we say the volume of soil requiring treatment goes up like this. But at site B, when this standard becomes more stringent, it could the amount of soil requiring treatment could go up much more sharply. Now, in traditional decision making, we look at these two sides. The decision making process would be similar. There would be no difference. I mean, if we go 10 to minus 6, I mean, at both sides, we will go to 10 to minus 6. But scientifically speaking, we can easily say that at site A, going with the most stringent standard requires much less work, right? At site B, it requires a lot more work. So the decision-making process should not be the same. Based on this rationale, we conducted a study at an actual remediation site. We found indeed, at an actual site, the second case seems to match with the actual site better. When the remediation standard becomes more stringent, the amount of work and also the cost of remediation goes up very sharply. So if we take this into account, if we think about the environmental cost of this additional work, then the traditional approach will be changed. So if we look at the net environmental benefit, we no longer only consider the benefit, we also think about the cost. And when we look at the net benefit, we will find that there is an optimum. In comparison, in the traditional approach, the remediation goal is usually depend on a arbitrarily defined acceptable risk level. But in the new approach, we can actually, using a mathematical approach to find an optimum remediation goal. And in order to find this optimum goal, we need to quantify both the environmental cost and the environmental benefit. And we used in our study, we were able to do this quantification, and we find a optimum remediation standard, which was less stringent than the regulatory standard that we referred to at the time. Now, as I mentioned earlier, in the remediation field, in sustainable remediation, we need to look at not only the environmental impact, but also social and economic aspects. And for this, we also did some study. We used an economic input and output approach to quantify like the cost, the employment, the impact to nearby property value, and also impact to workers' safety and local traffic. We used this proxy to quantify the social and economic impacts. Next, I want to introduce the concept of primary, secondary, and tertiary impacts in sustainable remediation. The primary impact is associated with the physical state of brownfield sites. This is primarily the health risk of site associated with contaminants. And the secondary impact is associated with remediation activities. It covers the energy and the material consumption, which is the life cycle impact beyond the site boundaries. And also the tertiary impact, which is associated with post-remediation usage of the site. Traditionally, decision-making primarily look at the primary impact, but not so much based on a quantitative approach. It's more based on the health risk assessment, on look at the risk level. And the secondary impact is now more widely adopted in the green and sustainable remediation movement. The tertiary impact has not been widely evaluated. This is a relatively new concept, this is more based on consequential impact assessment, which is also a new research direction in life cycle impact assessment. Next, I want to introduce a case study in which we try to combine primary, secondary, and tertiary impact. In this case study, we build a conceptual framework to combine all three types of impacts for a city-level assessment of greenhouse gas emission associated with all three types of impacts. We selected a city in San Francisco. We used the data from California to identify the number of sites and compare that to the city of San Francisco, and then to finally determine the amount of remediation work that is required. And we, for the consequential life cycle assessment, we also needed to determine the housing market in California and in San Francisco. So here we are presenting the type of housing, including single-family house and multi-family house, and their spacing, heating requirements, and also different type of fuels and electricity are required. Based on those data, then we combine that with the contaminant sites analysis. We identified around 200 contaminant sites in the city, and we used our assessment approach to quantify the primary, secondary, and tertiary impact that are associated with the brownfield development at these sites. The results were quite interesting. First, we see that the primary impact is relatively small, and the secondary impact is quite significant in comparison to the primary impact. So, which means that the remediation activities at this site will cause a significant amount of greenhouse gas emission. However, the most interesting part is that we see by doing brownfield redevelopment, we could create a lot of environmental benefit because of the change in the land use. And that is over one order of magnitude higher than the secondary impact. To summarize for this case study, on the one hand, we see significant secondary impact. On the other hand, we see tertiary impact, which is often ignored in life cycle assessment in literature. We found when they are combined, the climate change mitigation potential is very significant. It's equivalent to nearly 14% of the annual emission over 70 years. This is mainly attributed to reduce the household electricity and space heating energy and shorter commute distance. Now, at the end, I want to quickly go through some recent progress and current status in the green and sustainable remediation development globally. We did some questionnaire survey from the remediation community globally, and we found that the awareness of sustainable remediation is relatively high globally, especially in developed countries. And the adoption rate is also relatively high at developed countries, but relatively low in developed countries. This means in Asia and other developing countries, there is a strong demand to increase the actual adoption. And we also did a specific survey in China And it's similar to other developing countries. I mean, most people know, but don't know how to do it. They know about the concept, but don't know how to do it. And most people think sustainability should be included into decision making. But they don't think China is effective in adopting green and sustainable remediation. So driven by this demand, over the past 5 years, we developed a technical standard. This is the first green and sustainable remediation technical standard in China. It was published in early last year, and currently we have used this technical standard in a number of contaminated sites, and also we are drafting a national policy for the Ministry of Ecology and Environment to further promote green and sustainable remediation in China. And this is some screenshot of the technical standard. And at the end, I want to say a few words about what we can do in moving into the future. I think on the one hand, we need to enhance the education, educate both college students, professionals, and the public about sustainability. And we also need to further develop pertaining technologies. Firstly, is to develop more in situ remediation technology. I think in this regard, geotechnology has a lot to play. Second is to minimize energy and material consumption. And thirdly is to develop more green materials like biochar and other industrial waste-based material. And finally, is to further develop risk management approaches, for example, monitor the natural attenuation approach. So with that, I'm finishing my presentation. Again, I want to thank you all, and thanks to the organizer, and thank you, Professor Du.
Thank you, Professor Hou. Very impressive lecture. Well, because time is very limited, we have to move to the next speaker. As you know, for the four speakers, they both talk about the sustainable binders and the sustainable material as sustainability assessment. Our next speaker also is talking about the sustainability in urban area. So our next speaker, Professor Hou, thank you very much.